Hello, am I audible? Am I audible? Okay, fine. Okay. Is the screen visible? Is the screen visible? Okay.
So,
Acha, kindly do one thing, one favor. Say this girl Kajal Kushwaha to just switch off her mic. Okay. Agam, are you there? Agam Jain, are you there? Agam, are you there? Hey, you can put on your mic and respond. Any one of you. Are you there? Am I audible? No, yeah, it's okay. Uh, okay, now I need one name. I need one name like Atharv or any one of you from BX who can at the end every day will be taking up the attendance. That means the screenshot of it. Can you voluntarily come up and say a yes? Kush, Gelot, you recommended Kush. Okay, so Gehlot, you can also take it up, right? Gehlot, can't you take it? Okay, so Akshay, you will be taking up, and if Agam joins, tell him. Okay, you will take. Fine, fine. That's pretty fine. हाँ सर गहलोत ठीक है चलो चलो गुड ठीक ठीक है good. So what you are going to do is आप अपने end पे you will be putting up a folder named जैसे आज 14th May है तो 14th May BX attendance this is the stuff that you'll be writing for that particular folder, right Gehlot? Okay, fine. Akshay is good. Chalo. So let's begin for today. The place where we left yesterday was here. We were talking about the values for the attributes. Today we'll be talking about choosing the granularity. Medha, please switch off your mic. Fine. So choosing the granularity, right? So let us start up with the basic structure. I'll just try to take you a little back. While we are talking about the semantic nets, and gradually, when the structure that was supposed to be required became much more integrate or much more complex, let's say we need to represent a proper structure for more than one slots, or in fact more than one attribute classes, then what we did was we shifted from the semantic net towards frames, right? We gradually shifted from the semantic net towards frames. Now, as far as you can remember, what can be the simplest frame structure that can be created for knowledge representation? The simplest frame structure that can be created for knowledge representation is when we are having lesser number of slots. I hope you'll be agreeing with me, right? When we'll be having lesser number of slots. There can be another case like the slot number is higher, but the attribute values corresponding to a particular slot must be at least to a certain extent as low as possible. I'm not going through the slides right now. I'm just trying to recollect you certain what should I say, certain do's and don'ts or certain characteristics of the frames and semantic nets, right? So for the time being, let's say we are having a frame and we are having multiple slots for its various categorical representation within that particular frame for a particular physical object representation. In those frames, the attribute values that will be there, what are you gonna do for that? they will be utilized either for the description of the frame or for joining them with another frame, right? Or for joining them with another frame. This is what we generally do, right? So if this is the thing that we are doing, then at this present moment, I'd like to draw your attention towards choosing granularity. Granularity means granular structure, right? How fine the structure should be. So this granularity talks about certain things, right? Those certain things are mentioned out here. Now look at the slides. What level should the knowledge be represented? At what level the knowledge should be represented? What should be its primitives, right? So should there be small number, or should there be large number of low level primitives or high level facts? Low level primitives means, let's say if I am talking about a top down architecture of a generalization and specialization scheme. So if I'm moving down for a company structure, if I'm moving down, then at the top we are having employees. Below the employees we do have the managers. Then below the managers we do have the assistant managers. Right? Gradually I'm going down. So as I am going down in the top-down architecture, the lowermost part is called as the low-level primitives. And as we go towards more specialized versions, like going towards the top structure or the higher level hierarchical structure, we call it as the high level facts, right? Now high level facts may not be adequate for inference. Why? Because we know that in frame structure, to somehow join two frames, we can join it via its slots, right? So that's why joining two low level structures are much more easier in the case of frames or in the case of semantic nets. I'm just out here, right? I'm just giving the explanations for this. Are yaar, koi kindly say to this girl Kajal Kushwa, kindly say to her, keep quiet. अरे हंस मत, उसको बोल यार. ठीक है, तो हाँ, तो high level facts may be adequate for inference, right? So let us now talk about what is granularity with a practical example. हाँ, please mic off कर लो, दिया होगा सब. हाँ, अब सुन भाई, अब एक एग्जांपल देखो. Suppose we are interested in some of the following facts. Let's say I do have a simple assertion, right? I do have a simple assertion or a proposition. The proposition is John spotted Sue, right? John spotted Sue. I am highlighting it. Just have a John spotted Sue. This is one of the facts or an assertion that has been provided. Now this could be represented in the predicate form as how? Now John, who's an agent, has spotted an object Sue, right? John spotted Sue. A simple predicate representation. This is X, this is Y, this is subject and the predicate part, and we have simply written the predicate representation of it. Fine. Now, such representation will make it easy to answer some of the questions. Now, this is the assertion that has been given. I have converted this assertion into a predicate form, right? In this predicate form, what is the use of a knowledge representation in predicate form? To extract information, right? Now, to extract information, I do have a question out here. Who spotted Sue, right? If my question is who spotted Sue, it will become very easy for the machine to reply back that John spotted Sue. It's very easy. Now, in place of this question, if I would have changed the question to did John see Sue, then what would happen? Don't see here. See, initially we talked about John spotted Sue. We represented it in the form of a predicate logic structure, right? And the question was who spotted Sue? Then immediately under prologue representation, the answer will come up as John. Factoid answer will come up as John. But the problem arises when the question is shifted by a little amount of, what should I say, a little amount of semantics has been changed, right? And we are putting here a word called see in place of spotted. Even though both these words are synonymous, but the machine will not be able to understand it. So to resolve these kind of issues, what we are supposed to do now, or what is the solution for these kind of problems for machine understanding? Now we can we can assign a few more facts, like here you can see it, x spotted y. X spotted y, this is a predicate representation of spotting something. So this implies, I do have an implication symbol out here, it implies x saw y. So if something is being spotted, if x spots something, that something is y, then that is equivalent to x's seeing that y, right? So in this level of granularity, we need a little higher amount of granular structure. That granular structure's addition is this part of the predicate that we have added, right? So let's move even further. So out of the various characteristics of knowledge representation, choosing the granularity was one. Previously, we have talked about the single valued attribute. We talked about the techniques of reasoning about the values, and now we'll be moving gradually towards set of objects, right? Now, what are these set of objects? Let us start up with some of the examples. If I say in a community there are, let's say, 1 million people are staying in a localized community. If I say person X does have this much amount of wealth, an X amount of wealth, waiting in the lobby. Wait. How many? I am audible, na? I am audible, na? And you can see the screen, na? कोई तो बोलो. Okay, fine. ठीक. कुछ तुम अटेंडेंस पे ध्यान रखो. अरे तुम अटेंडेंस का ध्यान छोड़ो, तुम इधर ध्यान रखो. उसको छोड़ो, कुछ को छोड़ दे, कुछ अटेंडेंस ले लेगा. छोड़, इधर आ. So let's say we are having 1 million people staying back at a certain place, and I'm talking about that person X is having this much amount of wealth, and then I'm talking about person Y is having another value of wealth. Then I'm saying person Z is having another unique set of amount of wealth, right? So these kind of structures, if I club them up together, or if I'm specifically saying, as I'm saying you now, then the situation becomes much more complex. Instead of this, instead of specifically assigning values to a particular individual staying back in a particular community, if I club them up together means I am making out a set of them. I am creating a set of them, a set structure of them, right? And if I say a person staying in a community of New York is comparatively much more affluent as compared to the person living back at Kenya or at Nigeria, right? So if I'm talking about this thing will give you a very, very clear-cut factual idea about that. If a person back at New York, he is staying back there, then he is obviously much richer than the person, a set of people who's staying back at Kenya, or a place that is less affluent than the previous one. So let us see some more examples out here. Like, consider the assertions made in these two sentences. What are the sentences? There are more sheep than people in Australia, right? There are more sheep than people in Australia, right? And the second one is English speakers can be found all over the world. What am I doing here is I am talking about the class of ship and the class of people in a localized area called as Australia, right? I am saying about not just one ship. I'm talking about the whole set of object called as the ship. It becomes much more clearer out here. So to describe these facts, the only way to attach assertion to these sets of objects is people, ship, and English. There is another good example out here. Just have a look. If the property is true, not example, these are some of the facts. If a property is true for all or most elements of a set, then it is more efficient to associate it once with the set rather than to associate it explicitly with every element of the set. This is what I was explaining with the community example, right? Now, to do this, we do have certain quantifiers. The first quantifier is the universal quantifier, and the second one is the existential quantifier. Existential quantifier cannot be clubbed up here because of the fact that we talk about certain individuals in existential quantifiers, right? Now, Here is another example. Assert example is assert, that means say a predicate. What is the predicate? Na elephant large. That means sentence wise, if I just try to expand it off, then what am I going to say here? That elephant is large, right? I am saying about elephant is large. Now from this particular predicate you can draw two inferences. What are those two inferences? Now, if I am saying that elephant is large, then the system may understand in the form of knowledge representation that the set of elephants is large. I am talking about a set of elephants which is large, or I am talking about anything that has got a name elephant is large, right? Like if I say, oh, this has got a massive size of the size of an elephant, right? So I'm talking about anything that is given or that is provided with the prefix of an elephant will be somehow regarded as something that is having a huge volume, that is voluminous. So clubbing up something in the form of set, you have to remember that how you are clubbing up, or you are making up a set of objects, how you are making up a set of objects. There are three ways in which set may be represented, like name an example, and extensions of the definitions to list in numbers and in some other forms. Forget about these three things, right? Finding the right structure. This is what I said. Okay, just a moment. Just a moment. See, your attendance will become important at this stage if things becomes better and we can meet. I don't know what's going to happen, because all these things are dependent on the government notices. If we happen to meet in May end or June, I'm not saying about, I mean, if at all that thing comes up, then it becomes easier. But if things are only on the basis of this online stuff, then remember, things will become critical, and at the end these things will be counted, right? So please try to make your presence as much as possible, because at the end the 25% of the marks that is there in the internal assessments for 5 marks of attendance and rest all things, there you will be facing some kind of problems. So please be there as much as possible, right? Finding the right structure. It is about structuring the information. Forget about it. You will be going through this parts, by your own. It is a simple theoretical one. Now we do have the knowledge representation using predicate logic. We are not going into the depth of it. Hold on. Another 3 people are supposed to join. कितनों को एडमिट करो भाई, ठीक. So these are simple predicate representation that has been here. Fine. Now we are seriously moving towards a very interesting segment. We are moving towards a very interesting segment. We are starting up with the logic part. The moment we are talking about the logic, then logic is concerned with the truth of the statements about any physical entity in this world, right? Now, logic basically comprises of what? Now, syntax, semantics, and inference procedure. Syntax, semantics, and inference procedure. If I broadly talk about the syntax, then they are nothing but the symbols that are used in the language representation. If I'm talking about the semantics, then I'm talking about the meaning part of that particular word that has been kept as a knowledge base. If I'm talking about the inference procedure, that means I'm talking about the methods of deducing further information. Sir, how क्या पूछे एक बार फिर से पूछो. Agamjan. Yes, we'll be talking about this. We'll be talking about how to write down the codes for this. We'll be talking about this. First, see the logic part of it. I'll definitely be talking about that. So these things here. Now we do have the logic as KR knowledge representation language, and these all things are there. let us come down to something that is more important, right? So, logic representation. For building a logic-based representation, there are certain necessities. Those necessities are user-based set of primitive symbols and associated semantics, right? This is the first requirement for logic-based representation. If if logic defines the way of putting symbols together so that the user can define the legal sentence in the language that represents a true fact, right? Now, logic also defines the way of inferring new sentences from the existing one. The moment we talk about new sentences, that means inferring something, obviously it is from the pre-existing information or knowledge. Just okay. I'm sorry for the interruptions because I have to add up the students who are waiting in the lobby. Sure. There are some again petty examples out here. Forget about them. Let us come to this part. So we do have the propositional logic. Remember what we are basically going to do now in case of knowledge representation. We're not going to the propositional logic part as a whole. We will be talking about the truth table and its further deductions in problem solving, right? So let us see how we do it or how we'll be doing it. A proposition is a statement which in English would be declarative sentence, obviously. A very small sentence that will either hold a true value or it will hold a false value, but it will never hold both the values at the same time. That means true or the false value at the same time. Some of the examples are the sky is blue, snow is cold, and we do have 12 cross 12 is 144. These are some of the examples that they are, right? Now, propositions are sentences. They can be either true or false, but never both. As I have said a few seconds back, a sentence is the smallest unit of propositional logic. You know it very well. If the proposition is true, I repeat, if the proposition is true, then the truth value is true. Please, from here onwards, kindly focus to each and every word that I'm saying you now. If the proposition is true, then the truth value is true. If the proposition is false, then the truth value is false. If the proposition is true, the truth value is true. If the proposition is false, the truth value is false. Let's say we do have a sentence out here. Grass is green. Its truth value is true on the basis of observation that has been made by an individual. What is this proposition? The proposition is yes, right? 2 plus 5 is equal to 5. That is a false statement. Does this false true for this particular statement? Yes, it is, right? Close the door. What is the status of the door? I don't have any cardinal value for it. Hence, I have said a no. Likewise, is it hot outside? There is no value representing the fact. Hence, we have said a no here. Likewise, a few more examples you can see. So, I'm just telling you to remember this fact. If the proposition is true, then the truth value is true. If the proposition is false, then the truth value is false again. Right. Now, this is just to remind you some more facts. Like propositional logic is fundamental to all the logics. Propositional logic is also called as the propositional calculus or sentential calculus and Boolean algebra. These all things these are simple facts about propositional logic. Okay. Now we'll be talking about the statement, variables, and symbols. Now, these are more related terms. These are a few more related terms as connective, truth value, contingencies, tautologies, contradictions, antecedent, consequent, argument, as given below. All right. Now let us see each of them one by one. If I'm talking about a statement, a simple statement is a sentence that can be either true or a false and does not contain any other statement as a part. That means I'm talking about simpler sentences and are basic propositions. They are represented by lowercase letters like P, Q, and R are the symbols of simple statements. Does an assertion only carry simple statements? The answer is no. They can have larger and compound or complex sentences. For a compound and complex statements, we can have multiple simpler statements added up together by using certain conjunctions, right? We do have connectives or operators. Now, all these operators will be going through in this particular table. We do have a formula base for this. We do have certain precedences. In the table below, we do have basic connectives and their symbols that are listed in decreasing order of their operation priority, right? That means they are having certain priorities. As we move down from here to here, its precedence value goes down. Now, operations with higher priority is solved first. Where it is solved first? Now, in the formula structure, as you can see here. In the formula structure, as you can see here. Now, let us see this table very precisely now. You have to solve an example immediately after this. So, please be prepared. So connectives and symbols is in the decreasing order of operation priority. The first one is, please pay heed, please pay attention. Assertion, that means I have asserted a fact P. That means P is true. The first one, but the first connective is assertion, that means I have said about P and P is true. Jugja bhai, I'm sorry for these disturbances. There are 79 students right now. Only from BX. Please call a few more. Now, the next one is out here, negation. So I do have the first assertion and I have put up a minus or a negation, not in front of P. I can have much more symbols for them listed out here. You can see it very precisely. It is better to forget about these. Kindly don't forget, remember about these, but you can avoid them and you can use only this kind of negation in front of P. So if I'm talking about P's negation, that means assertions negation, that I'll be talking it as P is false. If I'm talking about the conjunctions, that means P and Q, that means for something to hold true, for something to hold true, both P and Q are true. If I'm talking about a conjunction P and Q, that means both P and Q are true. If I'm talking about disjunction, that means or. If I'm talking about disjunction or, if I'm talking about disjunction and or for P and Q, that means if either P is true or Q is true or both is true, then this whole disjunction part will be holding true. I do have the implication. Implication is for P implies Q. Kindly pay attention here. P implies Q. P implies Q. That means P is true, then Q is true. Or P implies Q means P is true, then Q is true. Equivalence, that means both sides assignment operator is there. P and Q are either both true or both false. That means not audible. Not audible. Hello? Am I audible? Okay, Harshit, okay. Now, if I do have the equivalence, that means if I do have the equivalence like P and Q are either both true or both false. So, ab dheere we'll be seeing this truth table assignment for this. So in the truth table, what are the things that we do? We're just showing you a few examples. The important part is here, right? The truth value of the statement is truth or falsity, right? Examples are P is either true or false. Not P or negation of P can also be either true or it can be false. P or Q can be either true or false, and so on. So wherever I am talking about something being true, I am talking about something having a high value, that means 1. Whenever I'm talking about something having a f value, that means false, I'm talking about their value being low, that means 0, right? The true means 1 and false means 0. So a simple truth table for the basic operations that you can see for a knowledge representation, predicate forms as represented by P and Q has been shown in the truth table defining the basic connectives. मुझे आवाज नहीं आ रही है धाकड़, तुम्हें आवाज नहीं आ रही है? रुक जा भाई, रुक जा, किसको किसको आवाज, मुझे आवाज नहीं आ रही है. Is facing network issues. अब बाकी लोगों को आ रही है क्या? आ रही है सर, ठीक है बच्चा, ठीक है, ओके 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 ओके. So the truth table defining the basic connectives, please for God's sake इसको थोड़ा सा देख लो. The truth table defining the basic connectives. First value is P, second value is Q. Don't see this part now, rest of the parts को नहीं देखना. First combination क्या है? Now first P is true, Q is true. So the negation of P and negation of Q will be what? Now if P is true and Q is true, the negation of P, that means true value, is false. The negation of true values for negation of true value for Q is also false. So the moment I'll be putting up a negation here, this true will become a false here. I do have P and Q. If both are true and true here, obviously this AND for P and Q will give a true value. Very good. Now I do have an OR. If I do have a true value for P and true value of Q, then I'll definitely have a P or Q having a true value for OR condition. Then somehow for your understanding sake, I am leaving this part and this part for the time being. आप इसको देखो, ये दो कॉलम्स को, इस कॉलम को, लीव दिस कॉलम and this column, इसको मैं अभी बताता हूँ. If I'm talking about a bidirectional assignment operator, so if P is true, Q has to be true. That means if P is true, Q has to be true, or P is false, then Q has to be false. Is it there out here? Is it there out here? Yes, P is true and Q is true. Hence, P for both sided assignment is true. ठीक है? This is done. So now we'll be seeing P implies Q and Q implies P for this first line. So P implies Q. If P is true, then Q is true. P is my hypothesis and Q is my conclusion. P is my hypothesis and Q is my conclusion in this case. So if P is true, then Q is true will give me a P implies Q's value as true. Whereas Q implies P means if Q is true, then P has to be true. It gives me a Q implies P's value as true. I'm coming down to the next row out here. Let me do one thing. I have completed this first row. Let us come down to the final row, right? So if I'm having a P as false and Q as false, then obviously not of P will become a not of false. That means it will become true. If Q is false, then a not of Q will become a true. That means this falses will automatically become true and true out here. If I take up the conjunction, that means the AND for P and Q, obviously a false with a false, that means false and false will give me a false value. A false and a false or a false for P and Q FF value will give me a, that means P or Q's value will be a false here in the last statement. Here comes another one. P implies Q. That means P is false, that means if P is true, Q is true. So this part, since P is false, Q is false, will give me a value of true. I am coming down to this part, that means under all the cases, if P is true, then Q is true. If P is false, then Q is false. If P is false, then Q is false, so it becomes true. Now, Q implies P. If Q is true, then P is true will give me a true value for both the false values of P and Q. Now I am left with what? Now I am left with this second row and the third row. Gradually, let's talk about it. Initially we had both the true values and then we had both the false values. If most of you are understanding it, it's well and good. The problem arises out here. This value, this value, this value and this value. 1, 2, 3 और 4. अब अपने से देखो, आपको इसमें प्रॉब्लम फील होगा. उसका एक्सप्लेनेशन अब यहाँ पर है. Now we are having P's value as true, Q's value as false. So if P's value is true in my second row, then negation of P becomes a false and the negation of Q, which is already a false, becomes true. Right? कितनी बार वेट करोगे, कितनी बार? ठीक. So if it is true and false, then the negation of P and the negation of Q becomes false and true. Just the reverse of this part. Just the reverse of these two is out here. Now, if I'm talking about AND, that means something is true and something is false. Then it has to be a false one for obvious reasons. If I'm having P or Q, then for the second row, since P is true and Q is false, then either P has to be true or Q has to be true. Then this value becomes automatically true, right? I'm again leaving this and this out here and I'm talking about P's and Q's double assignment, right? So both sided assignment, if I'm talking about P has to be true. If P is true, then Q has to be true. If P is false, then Q has to be false. If this is the case, then it has to be false because one of them is false. Since Q is false out here, so this thing will become a false. Likewise, now we'll be talking about this critical part. This is what? Now, this implies if P is true, Q is true. Why this is false? To understand why this is false, it is out here. P is my hypothesis part and Q is my conclusion part. I am only concerned about P's true value. If P is having true value, then Q has to be true. If P is having a false value, then whatever value this Q carries, it doesn't matter at all. So you can see here, initially, P is true. So automatically, if P is true, then P is true if Q is true. So this part becomes true. If P is true and Q is false, then automatically, that means if P is true, then I'll be checking for Q's condition. Since Q is false out here, we are having a false in this part. I am concerned about P being true. So P is being true and rest all when P is not true, like in the case here, P is false, I'm not concerned about it. So I am putting up a true value here. The same thing is applicable in this column too, right? In this column also. Let us see. Q implies P. If Q is true, then P is true. Swishing, swish, Q. Q, swish, Q. Swish, आ चुके हो? Are you there? Swish. Okay, इधर देखो. See here. So we do have. अब हम इस कॉलम को देख रहे हैं. If Q is true, then P has to be true. अगर Q true नहीं है, Q कुछ भी और है, तो ऑटोमेटिकली मैं इन सारे वैल्यूज को ट्रू ले लूंगा, मुझे कुछ देखने की जरूरत नहीं है. लेकिन इफ P is true, then Q has to be true. You can check it out here. If P is true, Q is true, it is true. If P is true and Q is false, then I am taking up here Q is true, Q is false, and P is true, then it is true, because I am not concerned about when Q is false. Now here Q is true and P is false, automatically this thing will become false. And if Q is false and P is false, I give a damn to these kind of conditions, so automatically this thing will become a true. So either you can remember it as that whole of the thing you can very easily find out. The only problem that you're going to face here is this, and this value in the truth table. I can assure you that definitely you're going to have at least one problem, or maybe more than one problem, from this part, definitely from this truth table representation for under the heading of knowledge representation. So you are having this in front of you. I'll give you one more explanation for this. We do have tautologies. What are these tautologies? Now, a proposition, tautologies are propositions that are always true. A proposition, when it is always true, we call it as a tautologies, right? A tautology. Like if I'm putting up a P or a negative P, that means a positive P or a negative P, then regardless of the value of the P, the truth values will always be positive out here. Contradictions. That means it is always false irrespective of the value of P. It is always false irrespective of the value of P. That means if I'm having a positive value of P, I'm having a negative value of P, I'm putting up a conjunction in between them, whatever may be the value of P, it is always true. So if these kind of things holds, then I'll be calling it as contradictions. So you have to remember special cases of tautologies, contradictions, and contingencies. Contingencies are what? Now they can contingency. What is the meaning of this word contingency? Backups, right? So this contingency talks about whether P and Q's value is whatever, they can take up any kind of value. They can take up either a tautology or a contradiction. That means this is a hybrid one between tautology and contradiction. We call it as the contingencies. Antecedent and consequent, you know, the preceding part and the succeeding part, we call it as the antecedent and the consequent. Now what is your task is, do you have a pen and a paper with you? Do you have a pen and a paper with you? I want to see few more yes coming up on the chats. I want to see a few more yes. Harshit, good, fine. अब रुक जाइए. अब आप अपने you take out your page and a pen. Right. I could have put it out here, but there are some things which are better to be written than going in some other ways. Okay. Now what you got to do is 1, 2, 3, 4. You have to make out 4 columns. You have to make out 4 columns and 4 rows, and the 4th column must be a little thicker, and the 4th column must be a little thicker. Thicker means थोड़ा सा उसको चौड़ा बनाना है, ठीक है? It must have 4 columns and 4 rows, and the 4th column must be a little thicker. ठीक है? बन गया? चलो, अगर बन गया है तो कॉलम के हेडिंग में हम क्या क्या लिखेंगे ना? फर्स्ट कॉलम के हेडिंग में हम लिखेंगे P, दूसरे कॉलम के हेडिंग में लिखेंगे हम Q, तीसरे में P और Q, एंड फोर्थ वाले में वी आर गोइंग टू राइट P implies, that means छोटा p, implication का साइन, that means एरो वाला P implies, फिर ब्रैकेट के अंदर P और Q, फिर ब्रैकेट के अंदर P और Q, राइट? पहला कॉलम में हमने क्या लिखा था? P, सेकेंड में Q. In the third column, what have we written? P or Q. And in the fourth column we have written, as I have said you to make this fourth column a little thicker, उसमें हमने क्या लिखा है? P implies ब्रैकेट के अंदर P और Q. P implies ब्रैकेट के अंदर P और Q. अब मुझे कुछ और yes sir yes देखना है कि आपने ये कॉलम बना लिया है या नहीं. कुछ तो बोलो. ओके, गुड. ठीक है. अब P वाले कॉलम के नीचे आप 4 वैल्यू लिखोगे, राइट? ये कॉलम का हेडिंग आपने लिख लिया है. अब P वाले कॉलम के नीचे यू आर गोइंग टू राइट डाउन 4 थिंग्स. 0 0 1 1. P के नीचे 4 वैल्यू, मैंने बोला था 4 रो बनाने हैं, तो P के नीचे 0 0 1 1. Q के नीचे 0 1 0 1. P के नीचे क्या था? 0 0 1 1. और Q के नीचे क्या है ना? 0 1 and 0 1, right? And तीसरा वाला column, what you are having? The third column that you are having is P or Q, right? You are having P or Q. This P or Q में what you are going to write down? ना 0 and 1 1. That means 0, उसके नीचे 1, उसके नीचे 1, उसके नीचे 1. P और Q वाले column में you have to write down. ओहो, मैंने क्यों बोल दिया? हट. मैं भी इडियट हूं यार. इसको तुम्हें बनाना था. चलो, तुमने P और Q में भी लिख लिया यार. चलो, फोर्थ वाला कॉलम बनाओ. फोर्थ वाले कॉलम में क्या क्या वैल्यूज आएंगे? ट्रू और फॉल्स भी लिख सकते हो या 1010 में भी लिख सकते हो. फोर्थ वाला कॉलम, दैट मींस P implies P और Q. इस कॉलम के नीचे क्या आएगा? यू टेक अप 2 minutes ऑफ टाइम एंड मेक इट. ठीक है, 1 आएगा, फिर all 1. Yes, Chandan, it is all true. Good, it is all true. Fine, very good. अच्छा, एक this will be all true. ये जो फोर्थ वाला कॉलम होगा, ये all true होगा या फिर all 1 होगा, राइट? एक और हम देख लेंगे अभी, एक और प्रॉब्लम छोटा सा हम देख लेंगे, फिर विल कॉल इट अ डे. ये प्रॉब्लम क्या होगा ना? एक तो रहेगा, अब आप फिर बनाओगे 1 2 3 4 and 5. अब आप 5 कॉलम्स बनाओगे एंड fourth or fifth column will be a little bigger, right? Fourth or fifth column will be a little bigger. 5 columns बनाओगे, fourth or fifth column will be little thicker, थोड़ा सा thick होगा वो. तो first column will be P, second column will be Q. मैं कॉलम का हेडिंग आपको बता रहा हूँ. First column will be P, second column will be Q, third column will be not P, third column will be not P, fourth column will be not P and Q, third column will be not P and Q, not P and Q, and fourth column will be P and bracket के अंदर not P and Q, not P and Q. मैं दोबारा रिपीट कर रहा हूं. First column will be P, second column will be Q, third column will be not P, fourth column will be not P and Q, and fifth column will be P and ब्रैकेट के अंदर not P and Q, right? अब मैं आपको P and Q के वैल्यूज बता दे रहा हूं. P के नीचे, P का वाले कॉलम के नीचे व्हाट यू गोना राइट? 0 0 1 1 0, फिर उसके नीचे 0, फिर 1, फिर 1. Q के नीचे है 0 1 0 1. Q के नीचे है 0 1 0 1. बाकी के वैल्यूज को आपको पॉपुलेट करना है फॉर कॉलम नंबर 3, कॉलम नंबर 4 एंड कॉलम नंबर 5. यू हैव टू पॉपुलेट फॉर कॉलम नंबर 3, कॉलम नंबर 4 एंड कॉलम नंबर 5. दैट मींस नॉट पी वाले कॉलम को फिर से भरना है आपको, पूरा क्या क्या आएगा वैल्यू, एंड फोर्थ कॉलम को दैट मींस नॉट पी एंड क्यू वाले कॉलम को भी भरना है. कॉलम 3 रुक जा सुयश, 0 1 0 0 0 1 0 0 होगा कॉलम 3. ठीक है 0 1 0 0. Good. Column 4. I'm watching your chats. Column 4 all 0. Fantastic. Column 4 all 0. I'm so happy that you're listening to me. Column 4 is all 0. So nice of you. Thank you. ओके, गहलोत और आगम और सुयश, एनी वन ऑफ यू, आप थोड़ा सा अटेंडेंस का स्क्रीनशॉट ले लें और उसको सेव करके रखेंगे आज का डेट दे करके, दैट मीन्स 14th of May, दैट मीन्स 14th of May 2020 BX बैच। ठीक है, इसको थोड़ा ले ले। अभी मत जाना, अभी प्लीज डोंट गो, डोंट लीव द मीटिंग, डोंट लीव द मीटिंग, लेट द अटेंडेंस बी देयर, कीप द स्क्रीनशॉट्स इन अ फोल्डर। हाँ, ओके, गुड चंदन, गुड गुड, वेरी गुड। हाँ अक्षय, थोड़ा सा आप ले लो। Hey, I just want to ask you, is it okay? You're learning, na? You're learning, na? Okay, okay, good, good, good. ठीक है बच्चा, पढ़ो पढ़ो, थोड़ा सा पढ़ो, हो जाएगा। Completed. Okay, श्वेस हो चुका है ना? सर्व एम्प्लॉइज लगा दिया था गलती से, कोई कोई नहीं होगा, ठीक ठीक है। ओके ओके ओके, थैंक यू थैंक यू थैंक यू, गो, थैंक यू, ओके, थैंक यू थैंक यू थैंक यू, गो, थैंक यू।